All right, we're continuing with limits, and our first limit that we wanted to talk about is f of x equals sine of 1 over x. So to kind of model what's going on, let's make a t-chart. And x, and we have sine of 1 over x. So we would normally want to plug things like pi over 2, pi, 3 pi over 2, 2 pi in for the parentheses to evaluate sine, but this is 1 over x. So instead of plugging pi over 2 in, we want to plug in the reciprocal since it's in the denominator. So we want to plug, instead of pi over 2, we're going to plug in 2 over pi, because then when you plugged it into the denominator, it would flip. So this is the same thing as sine of pi over 2, which is 1. We can't have 0 in our denominator. But next one, what if we wanted it to be sine of 3 pi over 2? So instead of plugging in 3 pi over 2, we plug in 2 over 3 pi. And that would give you negative 1. Keep going with this. Then 5 pi over 2, that would give you positive 1. Then 7 pi over 2, you flip it to get 2 over 7 pi. You get negative 1. 2 over 9 pi would give you 1. 2 over 11 pi, that would give you negative 1. So you'll notice that our denominator is getting bigger. Pi, 3 pi, 5 pi, so on. The denominator is getting bigger. And when the denominator is getting bigger, that means our overall number is getting smaller and smaller and smaller. Our fraction is getting smaller and smaller. So we're approaching 0. So our fractions are getting smaller and smaller and smaller. That means they're getting closer and closer and closer to 0. So we're asking ourselves, what is the limit as x approaches 0 of sine of 1 over x? Well, this oscillates between 1 and negative 1. 1, negative 1, 1, negative 1. And that pattern is going to continue for forever. So as we're approaching 0 with our x values, our y values aren't approaching anything because it's oscillating. So it's not approaching a specific thing. Since it's oscillating between 1 and negative 1, the limit does not exist. It's not approaching anything specific. It's going to keep going 1, negative 1, 1, negative 1 for eternity, which is not the same. It's not one consistent value. Next thing is a piecewise function. So let's go graph it. So when x is equal to 2, we have our y value is 0. So we have a point at 2, 0. But whenever x is not equal to 2, we have a constant line at 1, at y equals 1. So basically what happens is you have 1 until you get to x equals 2, and then you have a hole, because you don't have a point at 2, 1. You have a point at 2, 0. And then it keeps going at 1. So if I was going to ask you, what's the limit as x approaches 2 from the right? As you're approaching 2 from the right, you're approaching the y value of 1. What's the limit as x approaches 2 from the left? Well, from the left, you're also approaching a y value of 1. So your overall limit, the limit as x approaches 2 of f of x, the overall limit is 1. But what is f of 2? You might be thinking that f of 2 is 1. However, f of 2 is 0. Because we don't actually have a point at 2, 1. It's approaching 1. However, the value of f of 2 is 0. All right, some basic limits to evaluate. The limit as x approaches c of b. b is a constant. So if you're approaching a constant, or sorry, if x is approaching a number of a constant, that would just be like, here's b, it's just some random number, and let's say here's c. So as x approaches c, your y value is b. So as x approaches c from the left and the right, you're still approaching the same y value of b. So an example of this would be, what's the limit as x approaches 2 of 3? So what that would look like, if we're going to go graph it, x is approaching 2, but this is a constant y value of 3. So as x approaches 2 from the left, y is approaching 3. As x approaches 2 from the right, y is approaching 3. So the answer is 3. So if you're taking the limit of a constant of just a number, it's just the number. So the limit of x approaches 2 of 3 is just 3. Next one, the limit as x approaches c of x. What you're going to do is you are going to start taking your number that x is approaching, you're just going to go plug it in for x. So the limit as x approaches c of x is just c. So the limit as x approaches negative 4 of x is just negative 4. All right, same thing. Limit as x approaches c of x to the n, you're still going to do the same thing. You're going to plug c in for x. So this is just c to the n. So on this example, you're just going to go plug 2 in for x. So this would just be 2 squared, which is 4. Alright, what if I wanted to find the limit as x approaches 2 of 4x squared plus 3? So you can think of this a couple ways. You could separate this into two different limits. You can find the limit as x approaches 2 of 4x squared plus the limit as x approaches 2 of 3. So on this one, we're just going to take 2 and we're going to plug it in for x. So this is 4 times 2 squared. Plus, if you're approaching, if x approaches 2 of a constant, it's just the constant, just 3. This is 4 times 4 is 16, plus 3 is 19. Or you could have just, from the top, plugged 2 in for x. This is 4 times 2 squared plus 3, 16 plus 3 is 19. So I want you to notice, I never drop the limit sign until I'm plugging the number in for x. So later on, we're going to have limits that are more complicated, and you're going to have to start like manipulating them. You don't want to drop your limit until you've plugged the number in for your variable. So your problem might have many steps, and it's going to be the limit. And then the step, limit, step, limit, step. You're not going to drop the limit until you plug the number in. Once you plug the number in, you no longer write limit because you've just evaluated the limit.